Good morning, everyone. It's time to start the morning session, the second day of the workshop. My name is Hiroshi Yoshino, Tohoku University. We can share this session. And there will be seven presentations. And before coffee break, we have four papers. And the speaker has 25 minutes, and 20 minutes is for presentation. And after 5 minutes, we can discuss. And after all the presentation, we'll have some minutes, for example, 20 minutes, which can use the general discussion. Okay? And with me, Dr. Yuan from New Zealand, you can something to say.
Thank you very much. Good morning, everyone in the room, and good morning, good afternoon, or good evening to the people who join online. So this morning we will talk about the airtightness. For the people who join online, you are very welcome to ask questions using the chat box, and I think we can start now. So let's introduce our first presenter.
Okay, the first speaker is the Kiyoshi Hiwatashi, Dr. Kiyoshi Hiwatashi from Taisei Corporation. It's okay for you to start? Please.
Good morning. Good morning. This is Kiyoshi Hiwatashi from. This is Kiyoshi Hiwatashi from Taisei Corporation. I present proposal to promote airtightness in non-residential buildings in Japan. This content is under study by the study group, a proposal for realization and dissemination of a system for airtightness in non-residential buildings toward carbon neutrality in the Consortium for Building Research and Development. Around 2000, the US and the UK began to establish measurement and evaluation standards for airtightness in non-residential buildings. Since then, airtightness of non-residential buildings and the accumulation of airtightness data have been progressing. In Japan, airtightness of a high-rise building was measured in the 1980s, and reference values for airtightness were presented. However, no progress has been made since then. To change this situation and promote airtightness in non-residential buildings, the following proposals are made. First, proposal to create a network utilizing current airtightness testing businesses for residential buildings. Second, a proposal to establish measurement and evaluation standards with reference to the UK and the US and the UK standards. Third, proposal for training content. Fourth, a proposal for setting airtightness performance requirements. Fifth, a proposal to approach the climate seasoned assembly. Sixth, recognition of sense of speed in the proposed schedule for the start of the system's operation. At first, I explained proposal to create a network utilizing current airtightness testing businesses for residential buildings. In Japan, IVEX is an association that provides training, testing, and certification for airtightness testing for residential buildings. IVEX is an organization affiliated with the Ministry of Land, Infrastructure, Transport, and Tourism. Business operators are registered after training and pass the GIS A2201 airtightness performance test method for houses using a blower course. About 1,100 business offices are registered nationwide. We will conduct a questionnaire survey of these offices to set if they are also interested in airtightness measurement of non-residential buildings. We will also encourage the creation of a community network. Objective is to have each region conduct a study session of airtightness testing method and airtightness installation for non-residential buildings. And the objective is to have them take on the role of spreading the information to the local residents. In addition, since airtightness testing equipment is very expensive for large buildings, it is necessary to consider a system in which multiple businesses in a region can take measurement together. Second, I explained proposal to establish measurement and evaluation standards with reference to the US and the UK standards. In the US, ASTM standards have been developed for a variety of airtightness-related content. The 16 standards listed in the table below cover areas of field and laboratory airtightness test method, materials, and commissionings. Standards in the UK were developed by ATTMA. The standard is based on ISO 9972 and is classified into 4 categories according to the complexity of the building as shown in the table below. There are no standards except for airtightness testing standards in ATTMA. In Japan, there are no standards for airtightness testing of non-residential buildings at present. This A2201 is a modified version of ISO 9972 for Japanese residential buildings. This A1516 is a laboratory airtightness test method for fittings. This B9330 is the standard for calibration method for general fan airflow. In Japan, there is a need to establish measurement and evaluation standards as soon as possible. In order to respond quickly, it is acceptable to initially introduce foreign standards basically as they are. Modification will be made as necessary. A candidate for standards would be ATTMA, which is simpler and explains specific procedures. ATTMA is based on ISO 9972, which is the same as GIS A2201. The ATTMA evaluation standards are for each building type. In Japan, there is currently no accurate data, so the same evaluation standards should be adopted as in the US. Standards for materials and commissioning should be supplemented with those of ASTM. The set pressure should be set from 50 Pascal to 75 Pascal in a stepwise manner, taking into consideration the number of test equipment required. The USS 2012 window unaffected method should be adopted. For the purpose of this simulation, a pattern in which the ventilation opening are not closed should be adopted as the basis in order to reduce labor and cost. Next, I explain airtightness class for fittings. Japanese fitting standards GIS A1516 and ASHRAE IES standards for airtightness performance are compared. Japanese standards are classified as A1 to A4. The standards are A2 or lower for general buildings and A3 for soundproofing, thermal insulation, and dustproofing buildings. There is also 0.5 grade for curtain wall. However, there are no standards for airtightness of materials and no standards for airtightness of exterior envelope of non-residential buildings. The ASHRAE IES standards are stratified into 3 categories. The standards for those assemblies have higher airtightness performance than the Japanese standards for fittings and curtain wall. It is considered necessary to reconsider the Japanese standard for fittings and curtain wall. Third, I explain proposal to training content. In Japan, IVEX conducts airtightness testing courses. This course is targeted at residential buildings, and there is no course for non-residential buildings. The length of the course is about 3 hours. Currently, it is conducted online. The total cost of the course, certification, examination, and registration is about $200. In the US, the case of the ABAA is mentioned as an example. The ABA has 3 types of training courses. The first is for building airtightness technician program. Blower door technician program is conducted. The second is auditor courses. Field auditor training is conducted. The third is installer course. For buildings, airtightness technician program is a comprehensive training program covering ASTM, CGSB, ISO standards, and USS test method. The course length is 5 days, consisting of 2 days of conceptual training, 2 days of hand-on training, and 1 day of performing a test. The training course fee is about $2,500 to $2,900. The role of the field auditor is performing quality assurance audits of air barrier assemblies on new commercial and institutional construction projects during installation. Course length is 2.5 days. The total fees are about $1,200 to $1,500. There are 2 installer courses. One is self-adhere fluid applied installer training course. The other is spray polyurethane foam and self-adhered installer training course. The course length is 2.5 days. The total fee are about $1,500 to $2,000. ATTM in the UK also has training courses for airtightness testers, each level similar to ABAA. Pre-planning for airtightness testing is important for non-residential buildings because they are larger and more complex than residential buildings. Therefore, it is important to have the training course that includes more detailed planning method and practical skills. Training on installation method and supervise is also necessary. In order to respond quickly, it is proposed the content of training courses in the US and the UK, which have proven track record be introduced directly to Japan at first. In order to increase the number of qualified personnel, subsidies for acquisition of qualification are also proposed. In addition, subsidies for the purchases of expensive testing equipment are also proposed. First, I explain proposal for setting airtightness performance requirements. In this study, new buildings in different jurisdictions where mandatory airtightness requirements were compared to new buildings without airtightness testing requirements. The results showed that buildings built with the intent to meet the performance requirements for airtightness achieved the target values. New buildings built without the performance requirements were generally shown to be less airtight. In Japan, the actual situation of airtightness performance has not yet been investigated. It is important to accumulate airtightness performance data and set the required performance. The number of non-residential building airtightness testing companies will be increased. The understanding of the public will be deepened in order to accumulate data. Fifth, proposal to approach the climate citizens assembly. Climate citizens assemblies were held at a national political level on France and the UK in 2019 to 20. This attempt is also spreading to local governments. In Japan, the first one was held in Sapporo in 2020. Recently, Musashino City and Tokorozawa City has been also hosted the current conference, and many local governments are planning to do so in the future. Members are randomly selected from the general public and are gathered in proportions that present a microcosm of society. The number of members range from a new few dozen to about 150. Citizens spend weeks or months receiving information from various experts, deliberating and making recommendations to the national and local governments. The national and local governments will make use of the recommendations in their policies. At the 2020 Sapporo Citizen Assembly, participants were asked to complete a questionnaire regarding their visions for their future lives. An analysis was conducted on the result of the questionnaire using the strength of support and the scattering of opinions as indicator. Improvement of residential thermal insulation and spread of energy efficient buildings are strongly supported, and there was little scattering in opinions. However, awareness of airtightness lower than that of thermal insulation. It is important to raise awareness of airtightness improvement. It is important to that network of airtightness measurement companies in each region create a system to disseminate information to the public. Sixth, I explain recognition of a sense of speed in the proposal schedule for the start of the system's operation. This is the proposed schedule for the target of having the system operational by 2030, whereas that is very tight schedule. it is necessary to start operation as soon as possible at the realistic speed. Thank you for your attention.
Thank you very much for your presentation. So now it's time for question and answer. Okay. Yes. Andrew.
I need a microphone.
Speak slowly and simply.
Okay. Well, I would like to thank you for your presentation, by the way, but I had a question in relation to what was said yesterday on the Building Energy Efficiency Act and the calculation of primary energy use in buildings. So my question is then, since there is little experience with airtightness in buildings in Japan, how is airtightness taken into account in this Energy Efficiency Act and in the calculation method that was presented yesterday? I'm sure it's up to you or someone else in the public to answer the question.
Maybe it's good for Tachi to answer the question.
Yes, I can.
Yeah, please wait.
I will try. Yes, it was explained by Mr. Imamura yesterday in the first session. And he mentioned that I think it was about 15 years ago. Before that time, we had a rule included in the regulation about airtightness, but only for residential buildings. But yes. But one reason why we exclude that rule from the regulation, one reason is it is impossible to check that airtightness by the measurement after the completion of the building, residential buildings. You understand? And that the relevant point is what happens if the measurement result is not compliant with the value. I think many people will be in trouble. You understand? And another reason is that the airtightness may not be related to the directly to the necessary characteristics of the building envelope. At that time, we thought why we need airtightness of the envelope, especially for residential buildings. And our conclusion, the first priority objectives of having the good airtightness is to realize good thermal insulation performance of the envelope. There are many cases at that time that the very cold air, for example, from the crawl space, coming into the envelope itself, and it deteriorated very much the effectiveness of having insulation materials in the envelope. But such kind of countermeasures in order to maintain the thermal insulation performance is not directly related to the airtightness measurement. For example, please assume that, for example, in each room, only the interior finishing, if they are very airtight in each rooms and halls, that house may have a very good airtightness by the measurement. But they cannot touch the airtightness of the cavity where the insulation materials are installed. You understand? So airtightness measurement can guide them, practitioners, to have a better thermal performance. But our conclusion at that time was that it was not directly to the thermal performance of the envelope. That's our conclusion. And there are several additional reasons why we need airtightness. For example, good balance of outdoor intake to different spaces in the houses. If the airtightness is very good, very simple exhaust-only ventilation system can work. Indoor whole space can be depressurized by using very simple exhaust ventilation system, something like that. There are several other reasons. But I think, in my opinion, airtightness for non-residential buildings must be more important than that for non-residential. That for residential buildings, because they have a very big HVAC system. The HVAC system can pressurize rooms, and which can cause much infiltration. So we are collaborating to each other how we can deal with that airtightness issues for non-residential buildings. Thank you.
And I'd like to add something. And for case in residential building, all new houses should be installed the mechanical ventilation system, and the 0.5 air change rate should be confirmed by the mechanical system. And for calculation of energy consumption, energy requirement, 0.5 air change rate is included for calculation for energy requirement. Is that right?
Yes.
Yes. Okay, so you like? Next. Okay. Also, thank you very much, Hiwatashi-san. Thank you. Okay.